Hi everybody, this is going to be our note for 5.2, solving problems using right triangle models. So we're going to be using what we learned in 5.1 using the primary trigonometric ratios, the sine, cosine, and tan, and we're going to use them to solve harder questions now. So recall, our acronym to help remember the primary trig ratios is SO, CA, it's an H, and TOA. Or the S is for sine, the O is for opposite, the H is for hypotenuse, A is for adjacent, and we just have to know what each letter stands for to get their proper ratio. So hopefully we learned this after doing the 5.1 homework. We should have learned that in order for us to solve questions that involve SOHCAHTOA, we need either two scenarios. So what we need is, in one scenario, we have two sides, and then we find an angle, or we have one angle, one side, and then we have to find the other side. So those are scenarios when we're doing these primary trig ratios. I'll have a triangle like this. Again, it has to be a right angle triangle. And I'll either have two sides that I can use to find an angle, or I'll have an angle and a side, which I can use to find another side, or I could have the angle and a hypotenuse to find another side. So as long as I have one of these scenarios, I can use these primary trig ratios. The other thing we'll have to remember for these types of questions is that there's usually going to be more than one triangle, and the question will take more than one step to do. And our best bet in many cases is to actually break apart the triangle into two smaller triangles. So let's get to a more complex problem here with example 1. It says find the length of side BC. Sorry for the edit there, I wanted to zoom in and it took a little bit of time. So we're going to find the length of side BC. If I look at my letters A, B, C, and D, well, side length BC is here. I want to figure out this length. What is the length of that side? So notice we don't have any measurements over here. Notice we have a 90-degree angle here. We have another 90-degree angle that's kind of split, but we don't know what these angles are. So we're not going to say it's like 45 and 45 because we really don't know. It could be another set of numbers. But we do see another triangle here. So we see that this triangle is connected to this triangle. Well, if I'm able to use this information to find out what this side could be, well, then I could use that information to help me figure out what this side length is going to be. And if I know angle measures in a triangle, then I can figure out what this angle is going to be. So what should we do first? Well, let's just figure out what the other angle is going to be over here. Well, I know this angle is 50 degrees. I know this angle, all of this is 90 because of that box is there. So 50 and 90. And then I don't know what this angle is, but I know all the angles in a triangle add up to 180 degrees. So for us to figure out what angle B is, angle B is going to be, well, if I have 180 degrees and I subtract the other two angle measures, 180 is the total, so 180 minus this and this have to give me what this is going to be. So this is going to be 40 degrees. So I know this angle is going to be 40 degrees. Don't be afraid to draw out or write in the diagram, or maybe you want to redraw this out somewhere, maybe bigger so you can see all this information clearly. But yeah, I'm just going to label it in here for now. So then, remember, when I'm trying to figure out a side length, what are our options here? Well, if I have two sides, I can find the angle. But the scenario they're giving us is, well, we have an angle and a side, and they want to find another side. So here they want us to find a side. So in order for us to find another side, I need an angle and a side. So I have an angle here. So I need another side somewhere to figure this one out. I don't know the hypotenuse. And I don't know this, but I could figure this one out using this triangle. So how can I figure what this one's going to be? Well, I'm just going to redraw this triangle. I'm going to draw it over here. I'm just going to partition that off. So we're going to draw this triangle over here. I'm going to be drawing a lot of diagrams for this. And if you're like, I'm not really good at drawing diagrams, I'm just drawing shapes. Everyone can draw shapes. You don't have to look perfect either. So we have 50 degrees here. I have 17.0 meters here. And we want to figure out what this side is. Well, that's this side of the triangle. So what is this going to be? Let's call this x. So using our primary trigonometric ratios, I have an angle, just like our theta. So let's say theta is equal to 50 degrees. And then we have this side, which is, according to this angle, well, I see this is opposite the 90-degree angle, so this is the hypotenuse, is 17 meters. And what we're trying to find is x. So from where our theta is, x is opposite from that. So our opposite is x. We don't know what that is. So using our primary trig ratios, I'm working with hypotenuse and opposite. So I'm going to use opposite and hypotenuse. I'm going to use sine. So what I'm going to do is for what side of the triangle is this? Well, this is A to C. So for side AC, that's this side here, I'm going to, remember we said AC and D here is just the triangle AC and D here. So I'm just trying to find what AC is going to be. So we said that's going to be sine theta is equal to opposite over hypotenuse. And then I'm just going to plug in everything I know. Well, I know theta is 50. The opposite is x. And the hypotenuse is 17. So now, well, how do I get the x by itself? Well, I see a fraction, and I see the number on the denominator. I'm going to multiply both sides by 17. Just going to do that. So then I get x is equal to 17 times sine 50, which I would just write into my calculator. Sorry, these brackets just mean multiplication here. So then I'm just going to multiply these to get x, making sure my calculator is in degrees. I'm going to press sine 50. I get that number, this kind of decimal, times it by 17, and I get 13.02. So we can say that side length is going to be 13.02, but let's just make it 13 for our sake. So I really should put the decimal in here, but since it's just an example for our notes, I'm going to make it 13 just so we don't have a weird decimal to work with when we do our math. So we know x is now 13. And if this was a test, I would leave 2 decimals, but it's okay. Just our notes. So we know this is now 13. So going back to our diagram here, this side length is now 13, which means the side length for this triangle, or the height of this triangle, I guess, is 13 in this case. So now that I have this and this, I now have a side length and an angle, so I can find another side here. So I'm just going to redraw this over here, just down here, where I have this triangle, not very well drawn. I should edit the video and not show you that I'm erasing this, but okay, 40, and we know this is 13. We want to know what that bottom part is, what this bottom length is. So I know that I have the opposite side. If you want to look at the big diagram, I know I have the opposite side here, and I'm trying to find this side, the side at the bottom. It's not the hypotenuse, because it's not opposite the 90-degree angle, so it has to be the adjacent side. So if I have the theta being 40 degrees, and I have the opposite being 13, and I'm trying to find the adjacent side, well, let's call that y this time. Well, if I have opposite and adjacent, I have to use tan. So I'm going to use tan here. I'm just going to erase this arrow. So I'm going to have tan theta is equal to opposite over adjacent. I'll zoom in a little bit more. So then I'm going to replace theta with 40, 13 over y, so the adjacent is y. So now what do I do if I have the variable on the bottom? Well, there's the long way and the quick way. I will just teach you the quick way due to our circumstances of not being in the classroom. So really I would multiply both sides by the denominator, then divide this side by tan 40, but to save time I'm going to tell you all you have to do is switch places with the y and the tan 40 here. So we get y is equal to 13 over tan 40, which would be equal to, if I calculated it, 15.5 meters. So that is our answer for the length of this side. It's 15.5 meters. So if we zoom out a little bit, sorry, I just had to refocus it and zoom out a little bit. So then I would check, does my number make sense here? 15.5 meters. We do have to remember that the diagram is not drawn to scale, so we don't have to measure them, but like, is 15.5 close to these numbers? And yeah, I'd say this kind of fits the realm of between 13 and 17. I mean, if it was like 105, maybe I'd say that's a little bit high. If we had like 1, I might say that's a little bit low. But 15.5 is kind of seems like to be in the realm of these measurements. So I think it's a good answer. So we saw more than one triangle. We broke apart the triangle into 2 smaller triangles, worked with the information we know, or knew, sorry, to get new information that we could use to figure out our answer. So, but notice the number of steps. Step number 1 was finding the angle. Step 2 was finding the other side using the other triangle. And our third step was finding that final side. So expect, quite a few steps. All right, example 2. The area of a triangle. Elsie's parents have a triangular front lawn. They want to cover the lawn with sod. How much would it cost to put sod if it cost 13.75 per square meter? Now, if you're not sure what sod is just like the grass. You know, when you have a lawn, you roll grass onto it if you have a new lawn. So it has some dirt on it underneath it too. So that's what sod is. So Elsie's parents want to cover this with grass, basically. And the amount of grass, it costs $13.75 per square meter. How much would it cost to cover all of this? So this is really an area question. If I know the area of the lawn, I can get that area, multiply by the price, and I would get the cost to fill up this lawn. But first I need to find the area of this triangle. So how can I do that? So think back to our area of a triangle equation. Area of a triangle is equal to the base times the height divided by 2. So I need to figure out my base and height in order to figure out the area. So the base I already know though. I mean, the base is 11. That's the bottom part here. So for me to find the height is from the tallest point to the base, which is going to be here. So I got to find out what this measurement is going to be. I do know that if it's going straight down like this, it's going to be a 90-degree angle. So even though this wasn't a right angle triangle to begin with, by me putting this line here, I can make a right angle triangle within this triangle so that I can use my primary trig ratios. Notice that, like in the last question, I do have 2 triangles, but it just so happens for this question I don't really need the information from this triangle. I just want to find this line, this height, so I can find the area. So now that we have the information we need from this diagram, I see I'm just going to need this triangle. So I'm going to redraw this triangle all the way over here just so I know what numbers I want to work with. So I'm going to draw the triangle here. I know my angle is 40 degrees. I know this length is, well, technically the hypotenuse because it's opposite the 90-degree angle. It's going to be 13. And a little bit of a trick, I don't like saying there are tricks in math, but here they mean the whole base here is 11. So we actually don't know what length this is, just from here to here. I mean, we could figure it out, but we really don't need to. So I'm going to leave this bottom part blank. We actually don't know what that is. But that's okay, because we said before, when we're doing these types of questions with primary trig ratios, that I always just need at least one angle and one side, and then I can figure out another side. So I could figure out the question mark, but that's not going to help me with the question. So I'm going to just find out what this side is going to be. So if I look at my angle, well, theta in this case is 40 degrees. And then this is the hypotenuse we said. We said is 13. And then this side is opposite my theta. So the opposite is going to be the letter h, which is our height. So what do we have? We have theta, opposite, and hypotenuse. That's going to be sine. Sine theta is equal to opposite over hypotenuse. So we'll sub in what we know. Sine 40 is equal to the opposite, which is h, because we're trying to figure that out. The hypotenuse is 13. I then have this setup where I see I have a fraction with a denominator. I'll multiply both sides by 13 so that the denominator here cancels out. I'm left with h is equal to 13 sine 40 on my calculator. I would just do that all in one step. All right, I'll show you here. Sine 40 equals whatever that number is. I want as many decimals as possible, so I just leave it in here and then press the multiplication button. I'll get my last answer times 13, and I get 8.356. I'm just going to round it to 2 decimal places to 8.36. So h is equal to 8.36 meters. Then I have to think, well, does that make sense? Well, this is 13, this is 11, so 8 is kind of in that realm, but this is a bit shorter than those two, so that does make sense. So now we have our height. So we're going to find the area now, because we have our height is equal to 8.36. So using our area equation, the area of the triangle is, the base is 11, the height is 8.36 divided by 2, and then we get, if I multiply and divide that, 45.98 meters squared. So perfect, we have the area now, we're done, aren't we? No, because we said, we have to answer the question, sorry. The question's asking us, how much would it cost to put this on if it costed this much? So now we know the area, we're just going to get the area. I'm just going to put a little box around this to separate it. We get the area 45.98 meters squared, and we multiply that by the price, and then we get an answer of $632.23. Now, if you're wondering, is this a lot of money? I'd say $600 is a lot of money, but that's how much sometimes getting this kind of stuff costs. So just to make you aware of that too. But the bigger picture is, I mean, given this question, if we knew these measurements, if this was your property and you knew these measurements, you could then yourself calculate how much it would cost, or about, an estimate of how much it would cost. So what we did was we got a bigger triangle, made a right triangle inside of that triangle. Then I had 2 triangles, but I just worried about finding the height here. But again, let's look at our steps. Step number 1 was using this triangle to find the height. Then we had to use the area once we had the height. And then step 3 was getting the price. So about 3 steps per question, and maybe each step has a couple steps within them, maybe one, like this was just kind of one step. But the key, I honestly think, is don't be afraid to redraw your diagram over here somewhere else. Don't be afraid to draw this so that you can label it the way that you want to. I mean, you can label it here too, but I find some students just write a lot in here, then they make a little mistake because it looks a little bit messy. So I just like to redraw things out, make it nice and clear so I can get my calculations as accurate as I can without making a silly mistake. So our last example, we're going to be drawing our own diagram for this. It says a tunnel runs through a mountain that is 780 meters high. If the ends of the tunnel are 67 degrees and 54 degrees to the top of the mountain, find the length of the tunnel. So I know as soon as it says draw your own diagram, everyone has a little bit of a, panics a little bit. That's very common. So let's draw this together. But again, it's not as hard as you think. A tunnel runs through a mountain that is this many meters high. So let's draw a mountain. How can you draw a mountain? Well, I said as long as you can draw lines and shapes, you can draw anything for this course. So here's my mountain. Like that. And if you're saying, oh, that doesn't look like a mountain, that looks like a triangle. There, now it's a mountain. A little bit of snow there. And it says the height of the mountain, from the top to the bottom, is 780 meters. Then it says if the ends of the tunnel, well, there's a tunnel going through, so let's put some tunnels going through each side. If you're like, I don't know how to draw those tunnels, I just drew part of a circle. So if these are the tunnels, they said the angles of these tunnels, the first one is 67 degrees to the top of the mountain, and the other one is 54 degrees to the top of the mountain. Well, why would they be different angles? Well, remember, mountains are naturally forming things. They're not going to be perfectly symmetrical, so it makes sense that maybe one is on a different angle than the other. I mean, technically, based on my diagram, I should switch these, but again, it's not drawn to scale. We're just drawing our diagram for our own benefit here. So by just drawing this diagram, it hopefully looks a little bit clearer now. I mean, if I'm discussing the height of this mountain, there's obviously a 90-degree angle here. And if there's a 90-degree angle there, there's got to be a 90-degree angle here. So again, we have our triangle, and when we put our line in here, it splits it up at 90 degrees. And now I have two triangles. I have this triangle, which has an angle measure of 67 degrees and a height of 780 meters. So we'll zoom in there. And then we have a second triangle, also with a height of 780 meters and with an angle measure of 54 degrees. And because we put our heights, or the height of the triangle in here, we have two 90-degree angles. So we want to figure out the length of the tunnel. Well, the length of the tunnel is from this end to this end. So really I want to find the length of this bottom part of the triangle. So for me to do that, I'm going to have to figure out what this length is, and this length is, and then add them together. So how can I figure out these lengths? Well, let's do it for our first triangle over here. This is 67, and this is 780. What are we trying to figure out? Well, I have, this is my theta. Theta is equal to 67 degrees. From this theta, the 780 is opposite to that. Oops, 780 meters. And I'm trying to find this side length here. I mean, this is the hypotenuse, which I'm not given. So what I'm trying to find is the adjacent, which is, let's say, x. So for this triangle, what I'm going to find is the adjacent. Sorry for the edit there, I just wanted to make this diagram bigger so it's a bit easier to see. So we have 67 degrees. Opposite from this angle is the 780 meters. And we don't know the hypotenuse, but I want to find the adjacent side. So which trig ratio am I going to use? Well, I have the opposite and adjacent. I'm going to have to use tan. So tan theta is equal to opposite over adjacent, and we're going to fill in what we know. So I know theta, 67. The opposite we know is 780, and we don't know what the adjacent is. So again, what we could do is multiply both sides by the denominator, and then we'll have x tan 67 equals 780. Then I divide both sides by tan 67, or to save us some time, I'm just going to switch places with these two. X is equal to 780 over tan 67. And then I get x is equal to, if I type that all into my calculator, I'm going to go to 2 decimal places, I get 331.10 meters. And if you want to just double check that on your own, please do so. And if I'm wrong, let me know, or leave in the comments or something. So I get this for the length of from here to here. From here to here. So from this side. So this adjacent side we found to be 331.10 meters. All right, for another triangle here, I'm just going to draw that a lot larger this time. 54, this is 780, and I want to figure out what this side is, which is also for this angle. It's not the hypotenuse, because that's this side. I mean, this side is opposite that angle, and this is the adjacent then. So again, I have theta is equal to 54. Our opposite side is equal to 780. And our adjacent side is, let's say, y this time. So I'm going to use my tan again because I have opposite and adjacent. Tan theta is equal to opposite over adjacent. And we get tan, our theta is 54, which is equal to 780 over y. You know what, I'll show the long way this time. So multiply both sides by y. I get y tan 54 is equal to 780. Then I would divide both sides by tan 54. These would cancel out because they divide to equal 1. And I'm left with just y is equal to 780 over tan 54, which is what we would have gotten if we just switched places with them anyway. So that's how we get that. But if you do this in the future, I'm okay with that too. So then once we get this divided by tan 54, and how would I do this on a calculator? Again, I'll show you. I'll do 780 divided by, bracket, tan 54 to ensure that this happens no matter what, doesn't change it at all. And I'll get 566.70. I could also do tan 54 is equal to that, and then 780 divided by my answer, which is I get the same thing. So 566.70. 566.70. So we have this length now. So we have the two lengths of the tunnel. We have two kind of half lengths here, where this is now 566.70. So if I know this and this now, to get the total, I'm just going to add these two numbers. So we get 566.70 plus 331.10, and we get a total of 897.8 meters. So then we see, does that make sense? Well, 780 from the top of the mountain to the bottom, so it kind of makes sense that 800, close to 900 meters on the bottom, that could be true. So that would make sense. It's not like it's like 10 meters or something. That wouldn't make any sense. So again, how many steps? For the first triangle, or the second triangle, and then for the total. So please don't be afraid to draw out your diagrams. That way you can see the triangles, you can see where the numbers are going, and you can figure out which of the proper trig ratios you want to be using. But again, expect about 3 steps for these questions. Here's your homework. If you have any problems, again, let me know and we can arrange some office hours. And thanks for your time.